Hi guys, welcome back from the ad break. We are still looking at inequalities, but now we are going to look at them from a quadratic perspective. Remember I said there's two types according to our mind map that we had. We've looked at the linear one. Now we're going to look at the quadratic one and try to see how do we then analyze that and how do we solve it. But firstly, we need to define it and see what form it comes in, right? Let's have a look at it. So, a quadratic inequality, or rather inequalities, are inequalities of the form ax squared plus bx plus c greater than 0, or the very same expression ax squared plus bx plus c less than 0, right? Remember, it's either greater or less than. But it can also include the equal sign. Now, I know some people will want to see the actual equal sign on the inequality, but because already the inequality is the main sign, I'm just going to add in a bar there, and this bar will mean or equal to. So the first one reads as ax squared plus bx plus c is greater than or equal to 0. You don't say equal to or greater than. You start with the greater than because that's the main inequality that we have there. The second one reads as ax squared plus bx plus c is less than or equal to 0. So it means this whole expression can either be 0 or less than 0, or this whole expression can be 0 or greater than 0. Now, when we want to solve this, we use a graphical approach. Guys, I promise you, if you master this, you will then get this correct. But the graph of y is equals to ax squared plus bx, so I'm going to draw this graph for you and then try to show you where this particular inequality thing comes into play when we are talking about a quadratic graph. So remember that this is when a is greater than 0, meaning it has a minimum value for the turning point. So it's like your smiley face. You remember when they spoke about that. Now, if you look at this, when you look at this here of the inequality, of this graph, I mean, everything that we have here will make this expression here, ax squared plus bx plus c, to be greater than 0. Why greater than 0? It's because this is more like your y, right? And remember, from a Cartesian plane perspective, any value of y that is above the x-axis is always positive. Anyone that is below the x-axis is always negative. So above the x-axis, it's a positive, below it's a negative. But that's not the only one. So my first solution will be x is less than x1, whatever the x1 is there. And because I have another solution, but in an opposite direction, I will then use the word or, because it is either this arm here or that arm there. So you can't say this arm and that arm. That wouldn't really make sense. So on this side, you will then say x is greater than x2. So it's when this expression is also positive. Why? Because it is above the x-axis. But as soon as it becomes below the x-axis, this less than 0 means that it is a negative, right? Remember that. Less than 0 means negative according to the number line. So my solution there will be the one that I use an and now. I don't use an or. So my x values will be greater than x1 and less than x2. So it's like it is in between two values. Now that's where the difference between the and the or comes in, right? The and means that it is trapped between two values. It is between this and that. But the or will mean that it's either this or it's that. So you can see how I'm showing you this based on the graph that I have. I said it's this arm or that arm there, but with the less than, it's between this and that. And then when you then say it using the inequality, you will say it's greater than the minimum value and less than the maximum value. So that's how you then look at the difference between this and part and the or part that we normally use when it comes to inequalities. Now, let's just do an example, right? That has to do with solving this using an inequality. So remember, this graph is a negative graph, right? But we hardly deal with a negative graph. I always say to you, with anything that you do, always make sure that the x squared, its coefficient is always a positive. So I will need to divide this by a negative. And to do that, it means this will be the same as 2x squared plus the 6x minus 5. But if you divide by a negative, remember, the inequality changes the direction. So now it's greater than 0, meaning it's now when it is positive instead of when it was negative. So in terms of a graph, if I want to look at this, it will then be, because we are still focusing on it as a negative. Remember, negative is always below the x-axis, right? For it to be below the x-axis, it will be that arm there, and it will be that arm there. Why is it two arms? It's because as soon as you divide by a negative, it then makes it a greater than. So it's like you are reflecting this graph and making it to be a graph that we are used to that looks like that. So it is that arm or that arm there. So my solution for this then will then be this arm that I have here and that arm there. But if I now make it to be a greater than or equal to 0, it means that 0 is part of the solution. And where is this thing 0? It is 0 on the x-axis, right? So at this point and at that point, that's where my solution is. And because we're talking about it being greater than that, it will then be trapped between these two values. But remember, I said if it has a bar, meaning it has the equality sign, we then shade our circles. So my solution on this graph will be between there, using a shaded circle from the minimum point to the maximum point that we are using. Now, the method for solving this algebraically, because I just showed you using the graph, firstly, you must make sure that you write it in standard form. So the inequality must be in standard form, where a is greater than 0. And how do you do that? If it's not, you divide by a negative in order to make it greater than 0. And you find the roots of the equation. When the other word for roots, we normally call it the critical values, which I will just say it's CV. So it's like the critical values. That's where we're going to use our starting point. So the two roots that you're going to find will be our starting point to talk about the solution. You then use either a table or a number line to check whether the regions of that inequality holds true at all times. Because remember, it's all about making the inequality to be true. A typical example will be x squared minus x minus 6. I said you must write it in standard form. Already you can see it is in standard form. Then you find the roots. The roots are like your x value. So this is minus 3 and x plus 2. So it means my two roots, as I've shown you here, will be x is equal to 3 or x is equals to minus 2. Remember, what did I say? I said we also call this critical values, because you will see some textbooks use the word critical values. Now, because we want this solution to be less than 0, to be less than 0 from the negative 2 going to the right, to the left of it, it's more like our graph is like that. So it's above the x-axis. It's above the x-axis. So that does not hold. But between the -2 and the 3, we are below our x-axis. So it means our solution will then be, we check this using the table as I said. If I take anything that is less than the -2 as a negative maybe 4, it will then be a negative answer. Then anything between the -2 and the 3 will give me a negative as well, and then anything greater than 3 will give me a positive if I substitute it there. And the other part of the root is x plus 2. I take anything less than -2 will give me a negative. But now let me actually show you what I mean, because someone might be asking, what exactly does he mean when he says take anything less than -2? So let's say my x is -3 plus 2. My solution will be a -1. So that's what I mean when I say it gives me a negative. And then if you take 0, which is the one that is between these two values, it will give me a positive. And when I take any number greater than the 3, will then give me a positive. Now the goal will be to multiply the two brackets, and if you do that, you'll land up on a table that looks like this, right? Where it's a minus, minus, plus, minus, plus, plus, and then you multiply them. Negative by negative gives me a positive. Negative by positive gives me a negative, and then positive by positive gives me a positive. But where do we want our solution? We want our solution to be a negative, meaning less than 0. So on this last part here, whatever that gives me a negative will then be my solution for this inequality that I have. So you can see automatically from this that it's when x is greater than -2, or rather, and I mean x is less than the 3. So it will be between these two values that I have there. So if I write it down as a solution, will then be that's how I will then write it down. So firstly, always make sure that it is in standard form as an inequality. Find the roots. When I talk about the roots, I'm talking about the x values, right? Solve for x, factorize, and get to the two x values as though it's an equal sign. What do we call those? The critical values. And then plot them on a number line such that you then have a smiley face like that. Try to use a table in order to analyze where that particular solution will be either positive or negative, depending on what the inequality is that I gave you. I want us to take a quick ad break. When we come back, I'm then going to do specific questions now where I'm actually solving and showing you how to go about first writing it in standard form, finding the roots, and then representing it on a number line and writing your solution. Please stay tuned. I'll be back just now.